Hello everyone, welcome to my channel Physics Pro, and today is another interesting problem. So let's solve it. A solid cylinder of mass m and radius r rolls without slipping down on an inclined plane of length L and height h. What is the speed of its center of mass when the cylinder reaches its bottom? So at first we have a inclined plane. Okay, this is an inclined plane and a body rolls from the top. From the top means this here. So I'm getting some names A, B and C. Okay, and there is a rolling cylinder, a solid cylinder. Remember, that is a solid cylinder. Okay, this is not just a cylinder but a solid cylinder. So there is a solid cylinder and it rolls. Okay, and it rolls down and reaches to this point from C to B. Okay, and we have some data that the mass of the cylinder is m and radius is given r. Okay, and this height AC is given h. This is h, and the length, the inclined plane of length L. Length means BC or CB. I am writing CB. You can write BC also, but I am writing CB because it is the starting point C. So I am writing CB. Okay, this is our data. So there are no other thing. So directly we are going to a theory, and the theory will help us to solve the problem. The theory says that the total mechanical energy at point C is the total mechanical energy at point P. So total mechanical energy at point C is equals to total mechanical energy at point B. Okay, this is the idea, and this is called the conservation of mechanical energy. I am writing here again that this is called conservation of mechanical energy. Conservation of mechanical energy. If you have any question about this, if you have any confusion about the conservation of mechanical energy, ask me in comments and I will reply. Obviously I will reply. So there is the problem and we'll solve it. Okay, so total mechanical energy at point C. So there is no velocity, so there will be only the potential energy. Is that it? If there is no motion, then there is only potential energy. So what will be the potential energy in this case? M, G and H. Okay, and what will be the total mechanical energy at point B? At this point, look, the height is 0 at this B point. Okay, so what will be the total mechanical energy? There will be two terms. One is for translational kinetic energy. That is the total potential energy is converted to some kinetic energy plus why plus? Because the cylinder rolls. It is not only translating, it is translating through this way CB, and it is also rolling with some angular velocity omega. So there will be a rotational kinetic energy. Okay, very good. So what will be the translation and kinetic energy? This is half m v square, half m and v square, plus the rotational kinetic energy is defined as a half I into omega square, and I have defined omega. And what is I? I is some quantity I am writing where here. I is moment of inertia. Remember, when something rolls, a solid object, there must be some I. It is a solid object. That means not only solid cylinder, that it may be a hollow cylinder too. So solid object means that it is a extended body. Okay, remember, solid, I am writing here solid object. When we are talking about solid object, this means an extended body, not a point one, extended body. Okay, remember, this is very important idea, that if it is an extended body, then you have to take I, the moment of inertia. If it is not, then you can omit I. Okay, now half mv square equals to half I omega square. So what will be the I and what will be the omega? Okay, omega is nothing but v by r. Omega is v by r. V is the velocity of the body, the translation motion v, and r is the radius of the cylinder. Okay, very good. So we can put it here, and what will be the I? I. For solid cylinder, you have to remember that I equals to half m r square. For solid cylinder, remember this is not for all. For solid cylinder, it will change the value if we have different body. It will change. I will change. I will be changed. No, not I. That means moment of inertia I. It will be changed if the body is changed. Okay. So half m v square plus there is an half, and I is half mr square, and omega square means v square by r square. Okay. So we are writing half m v square plus 1 by 4 and this r square and this r square. So m v square, and this gives us something. Let's solve it easily. Okay, this is mgh. Okay, and this is 4, so this is 3 m v square. So m to m of, and there is v square, which is equals to 4gh by 3, and v is calculated by root over of 4gh by 3. So we have the option, which one? Okay, this is our option and this is our answer.